started our project by starting planning, and the planning phase is an important part of the building process. And as someone once said, sharpen your axe before cutting a tree. In other words, we need to be prepared. So in this stage, we talk about how we would approach the task, and we divided up the labor, and we also talk about how we would build it.
Alright, so the first part of making a circuit is building a truth table. So and it's the easiest way to um, uh, use Boolean logic to create a readable and understandable um, um, a readable and understandable algorithm to map out your circuit. Okay.
Then we made a logic circuit to organize our truth table and find out the exact sequences for our alarm system. We used the Yanka program, a suite of educational software products which lets students simulate scientific experiments, create mathematical models, design electric circuits, or learn computer programming to simulate whether our circuit would work. It also helped to determine errors and fix them before attempting the real thing.
That isn't ours. Yeah. Okay. Yeah. Ours isn't saved, but we used it to make sure that our resistors and our MOSFETs were working, and it actually helped us figure out a bunch of stuff. All right.
So the pin diagram was used to map out what we had to do on the breadboard. It made it easier to see where all the wires went in case we made a mistake. We could go back and check where it needed to go. And without this step, we would just be troubleshooting for things which happened.
So task distribution, or division of labor, is the specialization of cooperative labor in specific circumscribed tasks and like roles. Historically, an increasingly complex division of labor is closely associated with the growth of total output and trade, the rise of capitalism, and the complexity of the industrialization process. So we have our division of labor. So Ariana worked on the web log, the pin diagram, and the presentation. Bright worked on to map out the alarm circuit and design the web log. Cameron designed and built the alarm system. And Carol Ann mapped out the pin diagram and assembled the alarm. And Stephen worked on the Prezi and the alarm system. And I mapped out the pin diagram and assembled the alarm.
All right. So we had many failures and successes. A couple of which were the short circuiting of the switches, which is still a problem, but we ended up taping it together just to make sure it worked. Another thing that I used were MOSFETs, and that caused a bunch of problems that we had to troubleshoot, including drawing too much power and fueling an inverter. So we had to work around that, and one solution that we found was turning the MOSFET around because it acted backwards. So yeah, that, and while working on the alarm, we had grounded a certain part of the circuit that didn't need to be. So by using the device thing, I forget what it's called, multimeter, yes, we were able to figure out which wire that was. And so, yeah. Also, if you can see, we color coded our wires just to make it easier to see. So the green is for the green logic, yellow for the yellow logic, and red for red logic, and black for the and yeah.
Okay, so Cameron, can you show us what it looks like to test it?
You can just do it here.
So I can turn on one click. This is that. Okay. Not that.
look more into our project before we start, so we don't have so many things going wrong.
So we would have improved our project by coming up with a way to become more efficient in creating alarm. For example, by using less gauge or less wires, and we would have divided labor more equally in order to get things done quicker.
Again, we learned that time management is very important because of the time restraints, and also that the project conception is equally as important as the final product.
Some things we would have changed would be that we wouldn't improvise as much in the beginning, and also we would clearly delegate our responsibilities right when we get the project.